Hello everyone, and welcome to the videos for the review packet for cumulative test number 4. Please, at this time, if you have not tried the problems on your own first, I would suggest trying them and then using these videos as a resource. If you've been successful studying with using the videos first, I would suggest printing out another blank copy of this review packet and trying it on your own again before the test on Friday. So let's begin with number 1. We're trying to find the slope between 2 points either by using the formula or a graph. And before we start, remember that the slope formula, y2 minus y1 over x2 minus x1, is written this way because if we look at part B for a second, on the top, you're trying to find the difference between the two y values. And over here, if we drew a little triangle, the difference between the y values is found by subtracting the two values. Same with x. If I want to find the distance from here to here, you would subtract the distance from 5 to 0. And so because slope is always rise over run, it makes sense to me that rise is up and down, which is why y's are on the top, and why run, what we can do as human beings, side to side, is on the bottom. So after that, just reminder, because it's always good to understand where the slope formula comes from, not just what it is. Your slope is, so x1, y1, x2, y2, 1 minus negative 5 over negative 1 minus negative 4. In two cases here, my double negatives become a positive here and also become a positive here. So on the top, I really have 1 plus 5. In the denominator, I really have negative 1 plus 4, which is 6 over 3, which reduces to 2 over 1, or just 2. So my slope is a positive 2 over 1, or 2. In the second example, before I even start, based on the way the graph is going from left to right, it looks like we are falling. So because my slope is falling or my line is decreasing, I know that my slope will be negative before I even start the problem. Now, some of you asked me in class, how do I draw my triangle? Well, I would suggest, because the line is falling, I would fall first and then go to the right. Because remember, slope, again, is always rise over run. So if we think about how much we're rising, in this circumstance, we're really falling 2 units. And then we're going over to the right, 1, 2, 3, 4, 5 units. 5 is always positive when you go to the right. So my slope would be a negative 2/5. And also, as we talked about in class, this entire fraction is negative. So you could write your answer like this. You could also write the negative on the bottom if you'd like to, or you could just put the negative in front. So any of these 3 answers are possible. The only one that is not okay is if you wrote negative 2 over negative 5, this would change my fraction to a positive, so this is the only one that's not possible as an answer. Number 2 asks, if the rise over run of a line is 0 over 5, then the slope is what? Well, 0 divided by 5 is possible, and 0 divided by 5 equals 0 itself, so the slope here does equal 0. And if I were to graph that, my line would be perfectly horizontal, because this is possible but just has no steepness. Versus number 3, if the rise over the run of the line is 5 divided by 0, remember you can never divide by 0. So if you can never divide by 0, that means that your slope is undefined. And if you were to graph that on a coordinate plane, your line would be perfectly vertical, because this as a human being is not possible. And if you're skiing, you can't go directly to down. So this one is not possible or undefined. The next example continues with slope. It says find the value of r so that the line through 2, r and 4, 5 has a slope of negative 3/2. So because I'm given 2 points and I see a slope, I'm going to write down the general slope formula. And now I'm going to plug in what I know. I know that this first point is x1, y1. I know that this second point is the second x and the second y, or x2, y2. And I know that the slope, or m, is negative 3/2. So I'm going to replace n with negative 3/2. I'm going to replace y2 with 5, y1 with r, x2 with 4, and x1 with 2. If I simplify this side a little bit, the numerator are not like terms, so I'm going to leave it. But the denominator, 4 minus 2, is really 2. So now I have a fraction equaling a fraction, so I am allowed to cross multiply. Or in other words, 2 times 5 minus r equals this diagonal of negative 3 times 2. 2 times 5 minus r equals negative 6. Here, you could choose to distribute or just divide both sides by 2, whichever one you prefer. So this would be 10 minus 2r equals negative 6. Subtract the 10 if you chose to distribute. I'll bring my work up here. We would now have negative 2r equals negative 6 minus 10, or negative 16. We can divide both sides by negative 2 and get that the r value is positive 8. Now let's say on the test that you're not 100% sure that your answer is correct. Because you created an equation here, you could go back and check your work. So if you're interested in writing this down, I'm going to write a little check here. If I think that r is 8, that means that the first point would be 2, 8, and the second point would still be 4, 5. If this works, my slope should be negative 3/2. So let's see. 5 minus 8 on top, 4 minus 2 on the bottom. Yes, that does end up being negative 3/2. So my answer to the problem is really r equals 8, but I made sure that my slope was correct when I plugged it back in. So this is a really good technique for your test taking. Number 5, in 1950, the population of a town was 12,000 people. In 2010, the population grew to 19,500 people. Find the rate of change, aka the slope, from 1950 to 2010. So we're dealing with a change over time, aka slope. And if we want to find slope, that means that we need at least 2 points to start. So based on how the problem is written, what I'm thinking is that time is my x value and my population is my y value. So I'm going to write a little note that the x value is time and the y value is population, or people. So my first coordinate would be in 1950, the population was 12,000 people. Then in 2010, my population was 19,500. So if I want to find the rate or change or slope, we are following the idea that we're doing rise over run, or the change in y over change in x. So that would be 19,500 minus 12,000 over 2010 minus 1950. Order of operations says we have to simplify on the top and bottom first. So that would be 7,500 on the top, and in the denominator that would be 60. If I divide 7,500 divided by 60, that would get me exactly 125. But the question's not done until I have units, and it looks like the change is people per year. So it's about 125 people per year. Number 6, find the x and y intercepts of 5x minus 4y equals negative 20, and then graph the line using the intercepts. So this is the idea, the quick way of the cover-up method. So because this is in standard form, the fastest way to graph this would be find the x-intercept first and then the y. So if I want to find the x-intercept, remember that really means that y equals 0. So if we plugged 0 in here, it would really be covered up, and you'd be left with 5x equals negative 20. So x would be negative 4, which on the x-axis would be graphed directly here. So my actual intercept would be negative 4, 0. My y-intercept on the y-axis really means that x is 0. So if I plug 0 in here, this is covered up. So I'm left with negative 4y equals negative 20. And if I divide both sides by negative 4, I would get y equals positive 5, which, if I graph that as a point, would be 5 on the y-axis. So my intercept is really at 0, 5. And again, both of these points make sense because I plugged in 0, which is why it's in this position, and got out y is 5. Here, I plugged in y is negative 4. Along the x-axis, the y is always 0. So my graph would be just connecting these two dots. So this would be a picture of all my solutions here. Now that I have the graph, I'm asking, using your graph, what is the slope of this line? So I know these 2 points exist. So because my line is increasing from left to right, I would first go up and increase and then over. So it looks like I'm going up 1, 2, 3, 4, 5 units, positive 5. To the right, 1, 2, 3, 4 units. So my slope would be positive 5/4. And you can even write yourself a note that you're going up and then to the right. Number 7 asks you to find the x and y intercepts and interpret what they mean in terms of the problem. So part A is Tony's distance away from work. So my x-intercept, again, is when y is 0. So I notice in my table that my x-intercept would have to be 8, 0. And in terms of meaning, if I look at the original table, x would be time in minutes and y would be distance in miles. So if I'm thinking about my coordinate, minutes would go in the x spot and miles would go in the y spot. So if I'm interpreting what this means after 8 minutes, where is Tony? Well, if this represents distance away from work, if it's 0 miles, he's at work. So what I would say is at, or after, be a little bit better with my wording there, after 8 minutes, Tony is at work. The y-intercept is when x equals 0, because it's on your y-axis. So that would represent your y-intercept in terms of the problem. And if we're thinking about the units, this means to me, after 0 minutes, Tony is 9 miles away from work. But instead of saying after 0 minutes, remember we could say something like at the start or before Tony leaves. So in this context, I would say before Tony leaves, he is 9 miles away from work. Now this next problem is about the height of an airplane from the ground. So before we start, I changed a few things to make more sense. I said that the height was in feet by thousands, not by hundreds, because planes have to be pretty high up before they land. And I said time not in seconds, but I changed it to minutes, again, which makes more sense for the time it takes for a plane to land. So in this context, if I thought about what my x-intercept is along the x-axis, the only time this line hits the x-axis is here at 6, 0. And so my units look like my x-axis is in terms of minutes, my y-axis is in terms of feet by thousands. So if I have the point 60, this means to me that after 6 minutes, the plane is at a height of 0 feet or on the ground. So I'm going to say after 6 minutes, the plane has landed on the ground. If I look at the picture for the y-intercept, it looks like it crosses the y-axis at 0, 20. And for the sake of time in this first video, I'm going to write at the start of the next one what the intercept means, but I don't want to rush because I only have 15 minutes. So please pause this video now and please go to the second video for the explanation of the y-intercept.